Why AI agents get wrong answer even when everything works? Your AI agent didn't fail. It did exactly what you built it to do. And that's the problem. This is one of the most dangerous moments in AI agent development. The agent runs, the workflow executes, the log looks clean. And the answer is still wrong. Not because the model is dumb, not because the API failed, but because AI agents are systems, and the systems can execute perfectly and still produce the wrong outcomes. Today, I will walk you through the 4 real reasons this happens and why most team doesn't see until it's too late. My name is Celine Xu. Welcome back to my channel. I help business professionals and organizations make smart decisions about AI and AI adoption. So technology creates real value instead of risk. Reason number 1, external inputs that the AI agent cannot control. In many cases, the agent didn't actually make a mistake. The failure came from the environment or say the input. Let me give you a real example. A video editing AI agent was asked to create content using a model called Flex2, a second-generation, high-fidelity text-to-image model developed by Black Forest Labs. The agent searched the web, select the top-ranked result, continue execute exactly as designed, but the top result wasn't the official sites. It was a traffic capture domain that looks legitimate. From agent point, the tools return data, the rank looks valid, the pipeline execute correctly. So technically, nothing broke. But once we use the incorrect website, the information enter an agent system where the downstream step become wrong by definition. Agent not able to question truth, they assume outputs are usable unless explicitly designed not to. This is where risk enters. Whenever an AI agent consumes external information, search result, APIs, scraped data, the information is outside the agent's control and outside yours. That's why review is not optional. A mature agent system includes a validation layer, cross-checking, secondary reasoning, a separate validation agent, or a human in the loop. Without review, an agent becomes a highly efficient machine for turning bad input into confident, polished, wrong answers. And that review philosophy shouldn't apply only to external data. It should exist anywhere precision matters. Review is not a patch, it's an architecture. Reason number 2, when architecture becomes the problem. The second reason agents fail isn't intelligence problem, it's complexity. As system grow, we add more tools, more sub-agents, more workflows, more rules. It feels like progress, but complexity introduces distortion. Think about a company. A leader defines the strategy, an analyst interprets it, a manager translates it, and then finally, engineer implement it. At each layer, intents shift slightly. By the time execution happens, the outcome may be technically correct, but strategically misaligned. AI agents suffer from the same problem. In addition, there's another problem, we can call it the planner bottleneck. Execution agents usually work fine when scope is narrow. The planner must interpret intent, understand global objectives, select the right tools, and pass the right context downstreams. As capability grows, planner context grows relentlessly. The memory becomes the real issue. It is not only about the storage, but also about visibility, which means what information should be system see at which step. More capability should not automatically means more exposure, and more tools should not automatically means more context. As agents scale, the real challenge is not adding new intelligence, but control the information flow and windows. Sometimes a simpler or a more specialized architecture produces more reliable outcome. Reason 3, you have evaluation blind spots. Why agents return wrong answer is because you do not know is agent reasoning or reason correctly. Most of the time, the large language model is just a pattern matching but not really reasoning. And if in one production system, the back-end store only user input and final output, No planner decisions, no tool calls, no intermediate steps, no error record. You have nothing to check. On one interaction, everything worked. On the second, behavior diverged. Same user, same request, different result. And here are no record to find out why. You're blind. And you may ask why this differs from the traditional software checking. Because traditional systems are mostly deterministic, but large language models are probabilistic, which means small variant in context, memory, or tool response can shift reasoning paths. If you only log the beginning and the end, you cannot trace the chain. If you cannot trace the chain, you cannot debug or truly trust the system. Here, observability is not overhead, it's control. Without full execution trace, you cannot reproduce the behavior. You cannot detect logic drift or context difference. You cannot distinguish noise from signal. If you can't see how the system threw, you can't judge whether or not it was right. Reason number 4, you are using the agent to solve the wrong problem. Sometimes the agent didn't fail, you choose the wrong solution and evaluation metric. AI agents are adaptive systems. They interpret intent, they make contextual decisions, they adjust execution paths dynamically. That flexibility is powerful for ambiguous tasks. But not every task is ambiguous. Some workflows require hard constraints, deterministic output, guaranteed repeatability in exactly the same way. When you apply a probabilistic agent to a deterministic problem, you introduce unnecessary variability. The system isn't broken, it's misapplied. If you evaluate an adaptive system using a determinist expectation, it will always appear unreliable. This isn't about intelligence, it's about system mismatch. AI maturity also means know where to apply agent and where don't. The real takeaway: AI agents rarely fail because they are unintelligent. They fail because we misunderstood what they are. They are not magic decision maker. They are not traditional software or workflow. They are adaptive system operating inside the architecture we design. When the answer is wrong, even everything worked, it usually comes down to uncontrolled inputs, over-complex architecture, lack of observability, or using the wrong system for the job. In other words, the problem is rarely the model, it's the system design. And the system design is the leadership responsibility. AI maturity isn't about adding more capability, it's about adding the right constraint. If you are building or deploying AI agents in your organization, don't just ask, can it do more or right? Ask, is this the right system for this level of control? If you want practical AI strategy, not hype, not buzzword, but architecture that works in real business environment, subscribe and tell me in the comment, where are you currently use an AI agent and should it actually be a structured workflow instead? Thank you for watching and see you in the next one.